Welcome, curious voyager, to a journey not just through the vastness of space, but into the very fabric of reality itself. Tonight, we will gently explore the deeper, less visible dimensions and hidden realities of our universe, delving into concepts that stretch the imagination and whisper of cosmic truths beyond our everyday grasp. Beyond the veil, the hidden realities of cosmic dimensions and more invites you to contemplate the subtle curves of space-time, the enigmatic depths of black holes, and the theoretical realms of parallel realities. Allow your mind to relax, your breath to deepen as we drift through these profound ideas, letting the quiet immensity of existence guide you to a place of peaceful wonder and, eventually, restful sleep. Imagine for a moment that the universe is not just an empty stage where celestial bodies perform their dances. Imagine a distant galaxy, its light traveling across billions of light years towards our telescopes. Now, picture an enormous cluster of galaxies, an immense collection of matter lying directly in the path of that light. You are an intricate part of a universe where space and time are inextricably linked, forming a dynamic, responsive fabric. Every step you take, every moment that passes, is subtly influenced by the unseen curves and gentle flows of space-time. It is a constant, quiet dance, a seamless integration of existence that reveals a universe far more elastic and interconnected than our ordinary senses often perceive. A hidden truth gently woven into the very structure of reality. Just like a massive glass lens bends light, this cluster's immense gravity warps the space-time around it, bending the light from the more distant galaxy. What we see are not just distortions, but often multiple images of the same distant galaxy, stretched into shimmering arcs or even complete rings of light around the foreground cluster. It's as if space-time itself is acting as a cosmic magnifying glass, revealing faraway wonders that would otherwise be beyond our sight. Instead, picture a vast, invisible, four-dimensional fabric, like a colossal, flexible sheet that stretches across all of existence. This concept suggests that time itself can flow at different rates, depending on how strong the gravitational field is, or how fast an object is moving. Near a massive object, like a neutron star or a black hole, where space-time is severely warped, time would pass more slowly compared to a region far away in weaker gravity. Similarly, if you were traveling at speeds close to the speed of light, time for you would slow down relative to someone moving more slowly. While these effects are minuscule in our everyday lives, they are real and measurable, even affecting the accuracy of GPS satellites, which must account for time dilation to function correctly. Now, gently place a heavy bowling ball in the center of that sheet. Instead, the massive Earth is creating a deep, invisible well in the fabric of space-time around it. The moon, simply trying to move in a straight line through this curved fabric, finds its path bending continuously, falling around the Earth, the planets orbiting the Sun, and indeed, the stars orbiting the center of a galaxy are all engaged in this graceful dance dictated by the curvature of space-time. It is a silent, elegant ballet performed on a stage that constantly reshapes itself. What happens? The sheet dips and sags around the ball, creating a visible curve. If you then roll a smaller marble nearby, the marble won't travel in a straight line across the flat sheet. It will curve inwards, drawn towards the depression created by the bowling ball. This simple analogy, while imperfect, gives us a glimpse into the profound concept at the heart of Albert Einstein's theory of general relativity. What we perceive as the force of gravity is, in fact, the curvature of space-time caused by mass and energy. This is space-time, the fundamental canvas upon which every star, every planet, and indeed every moment of your life unfolds. What you might not intuitively sense is that this fabric is not flat and unchanging. It is profoundly elastic, constantly being warped and curved by the very presence of matter and energy. Think of it this way. Imagine a tightly stretched rubber sheet. So, when you see the moon orbiting the Earth, it's not because some invisible force is directly pulling it. This invisible curvature has some truly mind-bending consequences. One of the most captivating is gravitational lensing. Another, subtle yet profound consequence of space-time's elasticity is time dilation. So, as you lie here, relaxing, gently breathing, consider this. You are not merely existing in space, and you are not merely moving through time. You are an intricate part of a universe where space and time are inextricably linked, forming a dynamic, responsive fabric. Every step you take, every moment that passes, is subtly influenced by the unseen curves and gentle flows of space-time. It is a constant, quiet dance, a seamless integration of existence that reveals a universe far more elastic and interconnected than our ordinary senses often perceive. A hidden truth gently woven into the very structure of reality. From the subtle, pervasive curvature of space-time, these enigmatic cosmic objects are not merely voids in space, but regions where space-time itself has been so profoundly warped and stretched by immense gravity that nothing, not even light, can escape. They represent the ultimate cosmic portals, gateways to depths unseen, where our familiar laws of physics seem to converge on profound mysteries. Imagine a star, many times more massive than our sun, reaching the end of its life. What happens to matter and information once it crosses the event horizon? While purely hypothetical, a wormhole is envisioned as a bridge or shortcut through space-time, potentially connecting to distant points in our universe, or even different universes entirely. They stand as ultimate cosmic portals, silently demonstrating the universe's capacity for profound mystery and transformation. Their very existence challenges our everyday understanding of reality, inviting us to contemplate a cosmos far more intricate and wondrous than we might ever have imagined, gently guiding our thoughts into the quiet unknown. Mathematically, some solutions to Einstein's equations suggest the possibility of such tunnels, with black holes at their mouths. Imagine the event horizon not as an ultimate end, but as a potential doorway to another cosmic realm. A thought both profound and deeply calming in its expansive possibility. Does it simply vanish into the singularity, defying the laws of information conservation? This is known as the information paradox, a deep puzzle that continues to challenge physicists. And then there's the concept of Hawking radiation, theorized by Stephen Hawking, suggesting that black holes are not entirely black, but can slowly emit a faint thermal radiation, causing them to eventually evaporate over timescales far longer than the current age of the universe. Imagine these colossal cosmic devourers slowly, imperceptibly exhaling their existence back into the void. After exhausting its nuclear fuel, its core collapses inwards under its own colossal weight. If the remaining core is massive enough, roughly 3 times the mass of our Sun or more, the collapse continues unchecked, crushing all matter into an infinitesimally small, incredibly dense point known as a singularity. This singularity is the heart of a black hole, a point of infinite density where the laws of physics, as we understand them, break down. Surrounding this singularity is a spherical boundary known as the event horizon. This is the point of no return. Imagine it as a cosmic waterfall. Once anything crosses this threshold, it is irrevocably drawn inwards. Stellar mass black holes are formed from the collapse of individual massive stars, typically a few to tens of times the mass of our Sun. These are galaxy, silent remnants of powerful stellar deaths. Far more immense are supermassive black holes, found at the centers of nearly all large galaxies, including our own Milky Way. These behemoths can contain millions, even billions, of times the mass of our Sun. Their immense gravitational pull dictates the motions of entire stellar populations in galactic centers, and their activity can profoundly influence the evolution of their host galaxies. Light, matter, information, all fall towards the singularity. From our perspective, outside the event horizon, a black hole appears as a region of perfect blackness, a cosmic abyss from which no light ever returns. This is why they are called black holes. Black holes come in various sizes, each with its own quiet, profound influence on the cosmos. The existence of black holes raises some of the most fascinating questions in modern physics. Perhaps the most mind-bending theoretical implication of black holes is their potential connection to wormholes. The deeper we delve into the unseen depths of black holes, the more they reveal about the extreme nature of space-time and the potential for new, as yet undiscovered, physics. They stand as ultimate cosmic portals, silently demonstrating the universe's capacity for profound mystery and transformation. Their very existence challenges our everyday understanding of reality, inviting us to contemplate a cosmos far more intricate and wondrous than we might ever have imagined, gently guiding our thoughts into the quiet unknown. From the profound curvatures of space-time and the enigmatic depths of black holes, we now venture into even more speculative, yet utterly captivating realms of theoretical physics, the unsolved mysteries of parallel realities and hidden dimensions. Imagine that our universe, vast and magnificent as it is, might be but one shimmering bubble in an infinite cosmic foam, or perhaps that reality possesses more dimensions than our senses can perceive. These concepts, though unproven, ignite our intellectual curiosity and invite us to contemplate a cosmos far grander and more complex than we can currently observe. The many worlds interpretation suggests that every time a quantum event occurs, the universe splits, creating new, parallel realities where each possible outcome of the event actually occurs, and one dimension of time. But what if reality possessed more? Theories, like string theory, propose that the fundamental building blocks of the universe aren't point-like particles, but tiny, vibrating, one-dimensional strings. For these strings to exist consistently, string theory requires the universe to have extra spatial dimensions, perhaps as many as 6 or 7 beyond our familiar 3. Imagine stepping onto a path where every decision you could make, no matter how small, branches off into a new, separate reality where that choice was made. Does it diminish or enhance the uniqueness of our own existence? Rather than provoking anxiety, contemplating these vast, unproven possibilities can be deeply calming. It reminds us of the endless depths of reality, the boundless scope of what we might yet discover, and the humbling notion that our universe, while immense, is perhaps just one note in an infinite cosmic symphony. It allows our minds to expand, gently embracing the allure of the unknown, and finding peace in the boundless potential of existence beyond our observable cosmos. The leading idea is that they are compactified or curled up to an incredibly tiny size, far too small for us to perceive directly. Imagine a garden hose viewed from a distance. It looks like a one-dimensional line. They emerge from rigorous mathematical frameworks designed to solve profound puzzles in physics, such as why gravity is so weak, or how to unify all fundamental forces, while experimental evidence remains elusive. The ongoing search for subtle signatures, perhaps in the cosmic microwave background or in gravitational wave signals, continues. But up close, you can see its second, curled-up dimension, its circumference. Similarly, these extra dimensions might be curled up so tightly that they are imperceptible to us. Yet they profoundly influence the forces and particles we observe in our familiar dimensions. While difficult to truly conceptualize, it paints a picture of an endlessly branching cosmic tree, with each branch representing a slightly different, yet equally real, universe. This theory, sometimes associated with string theory, suggests that our entire universe, with all its stars and galaxies, might be confined to a three-dimensional brain floating within a higher dimensional space, often called the bulk. Imagine our universe as a sheet of paper and other parallel universes as other sheets of paper, all existing within a larger, unseen room. In this scenario, gravity, unlike other forces, might be able to leak into these extra dimensions, which could explain why gravity is so much weaker than other fundamental forces, like electromagnetism. This subtle leakage could be a whisper from another reality. One of the most intriguing and mind-bending ideas is the multiverse theory. This isn't a single concept, but rather a collection of theoretical frameworks, each suggesting that our universe is not unique, but merely one among an unimaginable number of others. Consider the inflationary multiverse. This theory, stemming from ideas about the very early universe, suggests that cosmic inflation, the incredibly rapid expansion immediately after the Big Bang, might not have ended uniformly everywhere. Instead, different regions of an ever-expanding, inflating superspace could have stopped inflating at different times, each giving rise to its own separate bubble universe. Imagine an endless, frothing ocean where each bubble that forms is an entire universe, potentially with its own unique set of physical laws, different constants, and perhaps even different fundamental particles. In this scenario, our universe is just one such bubble, floating alongside countless others in an unimaginably vast cosmic sea. Another fascinating idea arises from quantum mechanics, the theory governing the behavior of matter and energy at the smallest scales. Then there's the idea of hidden dimensions. Our everyday experience is limited to 3 spatial dimensions. Where are these extra dimensions? Even more mind-bending is the concept of a brain world. These ideas, the inflationary multiverse, many worlds, compactified dimensions. Brain worlds are not just flights of fancy. The philosophical implications of a multiverse are vast. If there are countless universes, does that mean every possibility exists somewhere? Does it diminish or enhance the uniqueness of our own existence, rather than provoking anxiety? Contemplating these vast, unproven possibilities can be deeply calming. It reminds us of the endless depths of reality, the boundless scope of what we might yet discover, and the humbling notion that our universe, while immense, is perhaps just one note in an infinite cosmic symphony. It allows our minds to expand, gently embracing the allure of the unknown, and finding peace in the boundless potential of existence beyond our observable cosmos. From the theoretical whispers of parallel realities and hidden dimensions, we now drift towards the most dominant, yet profoundly elusive components of our own universe: dark matter and dark energy. These mysterious entities, invisible to our eyes and undetectable by our current instruments, form the unseen scaffolding of the cosmos, dictating its structure and shaping its ultimate destiny. They are the shadow worlds of our universe, a different kind of hidden reality that invites us into a deeper immersion with the unknown. Imagine looking up at the night sky, seeing countless stars, nebulae, and galaxies. All that luminous matter, everything we can see, touch, and measure, makes up only about 5% of the universe's total mass energy content. It is not made of the same protons, neutrons, and electrons that make up ordinary matter. For decades, scientists believed that the expansion of the universe, initiated by the Big Bang, was gradually slowing down due to the gravitational pull of all the matter within it. However, in the late 1990s, observations of distant supernova revealed a shocking truth. The expansion of the universe is not slowing down. It is accelerating. Imagine throwing a ball into the air, expecting it to slow down and fall back, only to see it suddenly speed up and fly away, faster and faster, and dark energy driving expansion reveal a universe far more complex and mysterious than meets the eye. And finally, to the unseen scaffolding of dark matter and dark energy, allow these profound mysteries to wash over you. The universe is a place of endless wonder, where the known and the unknown intertwine in a magnificent tapestry. May the quiet immensity of these cosmic truths bring you a sense of deep calm, a gentle understanding that even in the vastness of the unknown, there is a profound peace to be found. They remind us that our understanding of reality is still in its infancy, and that the vast majority of the cosmos remains hidden from our direct perception. This unexpected acceleration implies the existence of a mysterious force pushing galaxies apart, a force that scientists have termed dark energy. Scientists are actively searching for candidates for dark matter particles, such as WIMPs or ixions. Using highly sensitive detectors deep underground, shielded from cosmic rays, we have contemplated the elastic fabric of space-time, feeling its subtle curves and the way it dictates the dance of gravity. There is so much that remains unseen, unheard, and unfelt. Yet its influence is undeniably present, shaping everything from the grandest galaxy to the smallest particle. As your thoughts quiet and your breath deepens, may the quiet immensity of these cosmic truths fill you with a sense of peace and boundless curiosity. Let the gentle hum of the universe, with all its hidden realities, guide you into a restful state, a profound and tranquil sleep. Good night. We've ventured into the enigmatic depths of black holes, those ultimate cosmic portals where physics meets mystery. We've whispered about the theoretical realms of parallel universes and hidden dimensions, expanding our very concept of reality. And finally, we've immersed ourselves in the shadow worlds of dark matter and dark energy, the invisible forces that sculpt and accelerate our universe. The search is like listening for the faintest whisper in a silent room, hoping to catch the subtle interaction of these elusive particles. The vast majority, the remaining 95%, is composed of these two enigmatic forces. Roughly 27% is dark matter, and about 68% is dark energy. Their very existence is a profound mystery, yet their influence is undeniable, a silent, powerful presence guiding the cosmic dance. One leading candidate for dark energy is the cosmological constant, first proposed by Einstein, which represents the energy density of empty space. If dark energy continues to dominate, the universe will expand forever, and its expansion will accelerate. This could lead to the big freeze or heat death we discussed earlier, where galaxies drift so far apart that they become isolated islands. Stars burn out, and the universe becomes cold, dark, and empty. It's a quiet, inevitable dissolution on an unimaginable timescale. As space expands, more empty space is created, and thus more dark energy comes into existence, continuously fueling the acceleration. Imagine the very fabric of the universe subtly stretching, and as it stretches, it generates more of the force that causes it to stretch even faster. Let us first consider dark matter. The evidence for its existence comes not from direct observation, but from its gravitational pull on the visible matter. Imagine a colossal, invisible hand guiding the motions of galaxies. One of the earliest and most compelling pieces of evidence came from observing galaxy rotation curves. Scientists notice that stars on the outer edges of galaxies were orbiting much faster than they should, based on the amount of visible matter present. It was as if there was far more mass exerting a gravitational pull than could be accounted for by the stars and gas we could see. This missing mass problem led to the hypothesis of dark matter, a substance that interacts gravitationally but does not emit, absorb, or reflect light, making it truly dark. Further evidence for dark matter emerged from studying galaxy clusters. These are the largest known gravitationally bound structures in the universe, containing hundreds or even thousands of galaxies. When astronomers observed how light from distant objects was bent around these clusters, a phenomenon we discussed earlier as gravitational lensing, the amount of bending indicated far more mass than visible galaxies alone could provide. It was as if these clusters were embedded within vast, invisible halos of dark matter, providing the extra gravitational pull needed to hold them together and warp the light. Imagine these immense, unseen clouds forming the gravitational glue that binds the largest structures in the cosmos. While we have strong evidence for its existence, the true nature of dark matter remains one of the most significant unsolved puzzles in physics. Now, let us turn to dark energy, an even more profound and perplexing mystery. Dark energy is thought to be an intrinsic property of space itself, a kind of cosmic pressure that drives the universe's expansion. The profound implications of dark energy are immense, particularly for the ultimate fate of the universe. These shadow components, dark matter providing the gravitational scaffolding for cosmic structures. As we conclude our journey through the hidden realities of cosmic dimensions, from the subtle curves of space-time to the enigmatic depths of black holes, as our journey beyond the veil gently concludes, allow your mind to drift back from the profound depths of cosmic dimensions and the unseen realities we have explored. These profound insights remind us that the cosmos is far more intricate and wondrous than our everyday senses can grasp. There is so much that remains unseen, unheard, and unfelt. Yet its influence is undeniably present, shaping everything from the grandest galaxy to the smallest particle. As your thoughts quiet and your breath deepens, may the quiet immensity of these cosmic truths fill you with a sense of peace and boundless curiosity. Let the gentle hum of the universe, with all its hidden realities, guide you into a restful state, a profound and tranquil sleep. Good night.